And we're live. Hello, and welcome to our virtual Lunch and Learn today. We're talking about motor control, design, and consideration tools. My name is Leanne Ireland, and I'm the Corporate Marketing Project Manager here at McNaughton-McKay Electric Company. Presenting for us today is Gino Porter from our Charleston branch and Stuart Newton from our Savannah branch. Out in the comment section, ready to answer your questions, is Gary Lopez, our Automation Engineering Manager for the Coastal South region. We'll have question and answers at the end for Gino and Stuart to answer in more depth as well. We'll be getting started shortly, but we love to allow a few minutes for attendees to join us. As you come in, let us know where you're tuning in from in the comments. As we continue to socially distance, we're happy to be able to host these live sessions on YouTube, making it possible for you to be able to join us from the comfort and safety of your own homes and offices. You can view recordings of previous virtual Lunch and Learns on our YouTube channel under the Virtual Lunch and Learn playlist. And we will be continuing this series every Wednesday at noon. So be sure to join us on your lunch break. For anyone just joining us, welcome to our virtual Lunch and Learn, Motor Control Design and Consideration Tools. Let us know where you're joining from in the comments. We'll be looking for questions as you have them in the comments, while our presenters, Gino and Stuart, talk about the a series that they're starting of basic methods for motor control. Our engineering manager, Gary Lopez, will do his best to respond to your questions in the comments as we go along. And we'll also have a Q&A segment at the end of Gino and Stuart's presentation to address some of those questions in more depth and to allow some time for any follow-up questions you may have. If you'd like to reach us afterwards for any follow-up questions for Gino and Stuart, you can send us an email at mcmclive@mc-mc.com. Be sure to let us know which session you attended, and we'll direct your questions to Gino and Stuart. We'll have the email address on the screen for you at the end as well. I'll also be putting it in the comment section. It looks like we have quite a few attendees now, so let's get started. Gino, I'll pass it over to you.
Thanks for the introduction, Leanne. Good morning, good afternoon, good evening to everyone across the world. Thank you for joining us on our weekly Mac and Mac YouTube live sessions. As Leanne discussed and shared today, we are going to briefly go over motor control design and consideration tools. Just to give you the lay of the land, we're going to start off with motor ownership, talking about where you'll see most of your issues when it comes to actual AC motors. And then we'll move into the different type of motor control devices that are used to control the speed and torque of your motors. And then after that, we'll transition into Premier integration. We'll discuss, that'll be Stuart's part, where he'll discuss how you can take advantage of the information that you can pull from your smart motor control devices over Premier integration. So without further ado, let's begin. So first and foremost, let's start with motor ownership. This is a really good graphic that outlines the typical causes of motor failure, and it divides it between mechanical, electrical, and other. 44% of your issues or motor failures are caused by mechanical issues. In that case, you will call your friendly mechanics from the mechanical shop to work on those issues. When it's not a mechanical issue, 44% of those times it'll be electrical. That 44% will comprise of 30% of it being overcurrent issues and 14% of it being single phasing. So what's the big deal? With this presentation, we would like to just basically focus on the electrical portion and what we can do to be more preventative on jumping ahead of the issues before your motor actually fails and causes you downtime, which will cause your plant potentially thousands, hundreds of thousands, millions of dollars. So with your motor control devices, your smart motor control devices, with them being networked, you now have the availability and the visibility to monitor, trend your current, thermal capacity utilization, your trips or different type of warnings, how much time has passed since you had a trip, how long has your motor been running, how many starts have your motor occurred, what's the voltage looking like. And for those that are looking to track the dollars that are being spent to turn these machines, you can monitor your energy and your power to keep your utility honest. So let's move on to our smart motor devices, smart motor control devices. The first one that we'll be starting with today will be the across the line smart starters. What makes these across the line starters smart? What makes them smart is that they have network capability. This smart overload, which is what makes the across the line contactor smart or intelligent, is powerful because one, becomes with embedded Ethernet, comes with 2 Ethernet ports, which will allow you to set 1 IP address, and that allows you to send many diagnostics, many of live real-time information to your integrated architecture system. Just like we mentioned in the slide before, over the network, you can monitor your current, the number of starts that have initiated, your thermal capacity utilization, how many hours you've been operating that machine, and so on. Many, when we use across the line smart starter, if you had a process or application or a motor where you just wanted to, as soon as you hit the go button, as soon as you initiate a start, you want it to ramp up to full speed as quick as possible. Across the line starter will be the solution for that. It's going to be the lowest cost between the 3 different solutions, and probably one of the more simple ones, the troubleshoot. The second type of technology that is used in motor control, a step above the cross-line starter, will be your soft starter. Your soft starter gives you a combination of basically a starter and some of the capabilities of a VFD, or a variable frequency drive, which essentially allows you to control the ramp, or basically instead of going between 0 to full speed instantaneously, right? You know, it's going to be some time between 0 and 60, but as fast as possible, all right? Your soft start gives you a controlled start. So you can set a time on how long it will take for you to get from 0 to full speed. For example, let's say my application was a fan or pump. I don't necessarily need that fan or pump to start to get the full speed in 1 or 2 seconds. I have more than enough time. I can set it to 10, 15, 20 seconds to have a nice progressive start to get the full speed. So what are some of the advantages of doing that nice smooth starts? Well, one, it'll help the mechanics out of your machine. So instead of it having a very violent start with it between going from 0 speed to full speed, especially has some heavy loading, maybe has some gearing on the back end of that motor on the front end. The soft start will help ease the wear and tear of your mechanics, of your mechanical hardware. Another advantage of having a soft start is that you have the capability to jog your motor in either direction. What does jog mean? A jog is typically out the box means running at 10% speed, but with your SMC soft starts, you're able to jog anywhere between 1 and 15% speed in either direction, with that being forward or reverse. Well, how is that so? With your soft start, the soft start is basically 2 machines in one. The first one is the part that allows you to ramp up from 0 speed to full speed. It's basically using the IBGT technology, where it's using pulse width modulation, which is seen in VFDs, and it allows you to control that the speed of the motor pretty precisely. And then once you get up to full speed, does the exchange, the contactor pulls in, and the IBGTs turns off, and then at that point it's just running just like a cross the line contactor. But since if you wanted to do a jog, the IBGT technology or your PWM, with using that type of technology, you can set the rotation of your current or your voltage to allow the motor to spin in either direction. Another good advantage of your soft start is that you can also throw these on a network. You can put these again on Ethernet among other networks, but Ethernet is slowly and quickly becoming the standard in terms of network topology. You can be able to, again, monitor your current number of starts, the energy that you've been using. If you have any type of warnings or trips, that information can be sent back to your PLC or to your HMI, and you can get that diagnostic information to make some preventative decisions to prevent, again, downtime. So moving on, third technology that we're going to discuss, and we're going to spend a little bit of time here, will be the variable frequency drive, also known as VFDs, frequency drives, variable speed drives. We're going to talk about some of the considerations that you need to consider when you're designing and installing these motor control devices. So let me move this picture out my way. So on the plant floor, over 50% of your energy is consumed by electric motors. So Rockwell's leading drive that I'd like to share about and discuss about will be known as PowerFlex. We discussed that on previous Mac and Mac Lunch and Learn. So today we're not going to be talking about the different type of drives, but more what the drives can do for your application, your processes. So going back, over 50% of energy is consumed by electric motors. The neat thing about variable frequency drives is that you're able to control the speed of your motor with this technology, from very low speed, 1% speed, to 100% speed, and even some cases over 100% speed. So you can control the speed and torque of your motor using a variable frequency drive. And if you reduce the speed of your motor by 20%, you'll save 50% energy. So if you are a power engineer, or if you are a bean counter, this tells us that if my power bill was $1 million and I was using cross-the-line contactors all throughout my plant, or I ran all my motors at full speed across my plant, if I went and reduced the speed of all my motors by 20%, you could effectively save $250,000. So that's if your power bill was $1 million. So that's where VFDs become very special, and this technology has been around for decades, but that's why VFDs are very desirable in plant applications. They're very easy to pay for themselves, and then start saving your plant money just by using this theory. So there are some considerations when you decide to install VFDs, variable frequency drives, into your plants, into your applications. We're talking about, this picture is a nice graphic provided by MTE, and it shows you basically for a power system and the scope of this presentation, where your utility feeds you power. Most cases it's 480 that we're dealing with. And on the input side of the drive, we're showing a aligned reactor. Then we're showing a drive, and then to the right of that drive, we're showing again another reactor, which in this case we're calling it an output reactor or a load reactor. And then finally we get to the motor. And so throughout the next couple slides, we're going to talk about why and when to install these devices, amongst other things. So let's start off with the input side of the drive. The first thing that you need to do, which is extremely important when designing your power system, when installing these, variable frequency drives, is to identify your ground system. And this can be identified by looking at your single line diagram. And typically your most common grounding system or power systems, would it be an ungrounded system, a highly resistant or high resistance ground system, or a solidly grounded system? And in the VFD world, we really want a solidly grounded system. So after you determine your grounded system, you'll need to take a look at your power jumpers. All drives, whether it's Rockwell or third-party VFD, are going to come with a set of power jumpers, and you need to apply the jumpers appropriately per the manual based on the grounded system that you have. And so if you have a solidly grounded system with PowerFlux drives, you will insert those one or both, depending on how many jumpers they have, into the drive. If it doesn't have, if you don't have a solidly grounded system, you remove one or both, depending on the number of jumpers that you have, out of that system. So to recap, identify your grounded system and apply your power jumpers appropriately. The next thing to consider on the input side of your drive is whether to use a line reactor. Many folks will consider line reactors as cheap insurance for your VFD. So why is that? So what does this graph show us? This graph shows us basically a reading with an oscilloscope on our drive. This green line, this green trend, is going to show your DC bus on your VFD. So in this case, it's floating. Typically, it floats around 650 volts, 678 volts. And they got it marked down below where it says V bus. Your blue line is going to be your AC input line connections or your line voltage. And then your red line is going to be your AC input current. So what happens? Where do you see the change? So over here on the x-axis, or the x-axis, you'll see at 37.50 minutes, a capacitor bank was closed, thus causing a disturbance on your line side of your VFD. Well, what type of disturbance did we see? Well, before this cap bank closed, our DC bus voltage was floating at 677 volts DC, and our peak current was floating at 32 amps. At the moment where the capacitor bank closed in to the circuit, whether it's due to power quality or some type of voltage sag, whatever caused that or initiated that capacitor bank to close, you can see at that moment the DC bus voltage jumped up to 108 6 volts DC, and the peak current snuck up to 507 amps. So this is very significant because, as you can see, the peak current went more than 10 times the nominal rate that the drive is used to seeing. So if you have a 40 amp drive, it's not designed to be taking in 507 amps along with the cables that are feeding that drive as well. So those are some issues that you need to design for. So how can we fix that? You can mitigate that effect by adding our line reactor. So just by adding a line reactor to the input side of your drive, you can reduce the effect of the capacitor bank closing. Instead of your current increasing from 10 amps to 200 amps in this case, it's showing that your nominal was 10 amps, and when the capacitor bank closed, it went to 19 amps. So that's a lot more manageable. We'll get more life out of our VFD, less downtime, and that pretty much tells the story. And then again, if you look at the bus voltage only creeped up to 653 volts when the nominal DC bus voltage was 637 volts DC. So again, to reiterate on the jumper configuration, as we discussed before, on your grounded system, if you have a solidly grounded system, right? If we go back a few slides, if you have a solidly grounded system, three wires coming in, you're neutral, it's grounded to earth. There's no resistor in between it. If you have a PowerFlex 750 drive, there's going to be two power jumpers. Both of them need to be installed. Both of them need to be connected. If you have any other grounded system that's not solidly grounded, they should be disconnected. And then let's discuss the output side of the drive. Some couple of considerations that you need to be concerned about with your VFDs is cable length. If you have a very long cable length, you can start running into issues such as cable charging current, and also reflective wave. Reflective wave is basically a phenomenon that happens when you have a very long cable length, and it causes the voltage to spike, a lot of times, sometimes double at the point of where there's an impedance mismatch at. So in this case, a lot of times it's going to happen between at the end of the cable and your motor termination box. There are other names for that, but for this presentation, we're going to call it a motor termination box. And you can see in this picture, these can be some of the effects. So in this picture is showing a winding inside of a motor that's been affected heavily due to reflective wave. Well, how is this so? This motor is designed for a certain voltage, right, that it can sustain. Since and this we'll show this in another graph, but since if the motor is not designed for an inverter duty rated motor, where it's expecting basically PWM, pulse width modulation, DC voltage turning on and off, and that voltage, as we saw in the graph before, that DC bus was around 650 volts. If we double that, that's around what, 1300 volts. So if you have a motor that's has an insulation that's rated for 1000 volts or 600 volts, that will give you issues. So it's important to, one, keep your motor lead length short so you won't have to deal with reflective wave issues. If that's not the case, specify and purchase and use an inverter duty rated motor so it can handle those large spikes. And then also there are some motor protection devices where you can basically suppress those spikes that happen at the motor termination box. And you can also, just like we did on the input side of the drive, install a reactor in between the drive and motor, and we call that a load reactor. So as we discussed before, this is basically a voltage measurement. You can see that when the voltage switches from, the PWM switches from a low to a high, goes to a high to a low, and there's a spike. And this spike, as you see right here, is caused due to the long cable lengths. And that can deteriorate your motors that are non-inverter duty rated or that's not supplemented with motor protection devices to help suppress these out. So what are some tools that you can use to monitor or view or trend reflective wave, harmonics, or power factor? One that I highly recommend is called the Fluke MDA, or a motor drive analyzer. Essentially, it's a high-end oscilloscope that has some firmware on it that is very friendly for the user that's in the field, whether that's your engineer or your technician, electrician, whoever is qualified to work on this equipment. From there, you can print out some nice report, get some useful information to, one, monitor the health of your motors or your drives, or in this case, your cables as well. Another consideration is to use reactors, a load reactor or a line reactor, to improve your power quality, your power factor, reduce reflective wave. Those reactors are, again, I like to call them cheap insurance for your VFDs and motors. A lot of times you can't go wrong with them. And so big picture, these across the line starters your soft starters, your variable frequency drives, and your motor control centers, where starters, soft starters, and VFDs, you can put these devices inside of MCCs. And again, we've been doing this for many decades. But with these being smart devices, that in essence makes our MCCs smart MCCs, and in our world we call them IntelliCenters. And the good thing about the IntelliCenters, all right, is that our IntelliCenters are loaded with a smart managed switch, which will allow us to pull all the diagnostics and information that we said was available for us in our VFDs, soft starters, and our smart starters, particularly in the E300s. So what we can do to, what type of information can we pull from that? Well, one, you can, using the IntelliCenter software, through the use of a clean HMI that's mounted on the IntelliCenter, you can easily trend your power usage, look at your energy data. You can see, have access to your event log. How many trips have you had on which motor? What time did it happen? And from there, you can take that information and say, hey, was it caused to a storm? Was it caused to a machine next to it, upstream, etc. So that's what really the beauty comes in, using an IntelliCenter, using pulling in these diagnostics, because if you're not pulling this information in over a network, you're missing out on a lot of capabilities of these smart devices that are ready for you to use. So without further ado, I'll pass it over to my colleague, Mr. Stuart Newton of Savannah, to talk about Premier integration.
Thanks, Gino, and thanks everyone for joining us today. I'm going to take a little bit of time and continue on and talk a little bit about the automation and control of the starting devices that Gino's already chatted about. First of all, I'd like to, I guess, take our minds back and remember how, the original starting devices were in fact activated. Obviously, way back when, before networks and all, we would operate these things on a standalone basis, probably in a manual mode, typically, push buttons, select switches and those things. And then with the advent of PLCs, we got some level of automation using discrete I/O to start the devices with some kind of a wiring solution. And then from then, with the introduction of simple networks like remote I/O, TH+, Modbus, there was a network option between the drives or the devices and the PLC. But really, I'm just starting this presentation now. We can see today the preferred network is in fact Ethernet. And this slide devices that Gino touched on, from left to right, from the smart starter, the E300s, all the way up to the motor control centers that can contain any or all of those other devices being connected up to a Logix processor over the Ethernet backbone. With Rockwell's case, it's an Ethernet IP network. They have their own SIP preferred language. And then obviously the Logix itself uses Studio 5000. So we like to think this arrangement offers some benefits. We see there the 1 + 1 is greater than 2. So with everything being manufactured and by Rockwell and the network being a preferred Rockwell solution, there are some benefits with those devices being together. So I'm going to go ahead and continue with a couple more slides that really discuss some of those benefits of what we would term as Premier integration. So one of the first benefits is with actually within the Studio 5000 software, and it's something we refer to as automatic tag generation, or where we map a device into the tag database. So as we see here over on the left pane, we've added a PowerFlex 755 drive into the project. We've named it heating water pump number 5, and simply on accepting that as an addition to that family, on the right hand side in the tag database, we see pre-populated tags and subtags. And obviously you see there the naming convention is transferred over. The heating water pump 5 is there, and all the subset of tags is automatically added. So all the logic commands, the starts, the stops, forwards, etc., are all pre-configured for us. So that really saves a lot of time and eliminates the chance of any fat-fingered mistakes when building the database. And obviously, you know, the PowerFlex is just one example of one device that can be added. It could be several PowerFlex drives, it could be the smart starters, and so on. So that the scope and potential here is significant when it comes to saving and saving a lot of time and effort. The next benefit is again in Studio 5000, and it's a one place, one configuration. Basically, again, all those devices can be added to the application, to the program, and all the parameters within that device can also be established and maintained, again, in one place. So Studio 5000 has the ability to allow us to configure anything from a drive to an intelligent motor starter, or even to sensors. We can do this one-point configuration. And also, obviously, it's configured there, and it's saved and maintained. So if it needs a backup or recovery, it's also done through Studio 5000. Obviously, this then simplifies commissioning and startup. The next benefit shown here of the Premier integration is actually from an operational standpoint. How it helps us, you know, in the field from a maintenance and support standpoint. We see here we've got the drives connected to Ethernet, to the Stratix switch, and onto the logics, similar to what we saw in the earlier slide. In the unlikely event that we lose a drive, it's simply replaced with the appropriate lockout tagout procedures. And then the switch, the Stratix switch, has got the DHCP port persistence, which will push an IP address to that drive. This will be the same IP address what was on the old drive that has just failed and been replaced. And then once the logic processor identifies that IP address, it will automatically flash and then push down the configuration parameters for that drive. So in this case, it certainly would lower time to repair and possibly eliminate the need of a technical person to do that, maybe a mechanic or electrician, someone just simply to replace the hardware, and then the software is replaced automatically. Another benefit, again, of the Premier integration is the visualization side. Here you can see there's a pre-configured, what we call a faceplate, with a number of parameters and status information. This is actually an E300, an intelligent overload, and basically all that information that's seen there is available to us. And this is a quick container. Again, it's pre-built with just one connection into the tag database, can bring forward all this information, analog and discrete, and this graphic can be used at an operations operator interface level, or at a higher level on an HMI, which obviously means then there's a good level of consistency of graphical representation across a site. Finally, here there's just one of the benefit is remote monitoring, and remote could mean, you know, same site, different room, or it could be a you know, an office or building elsewhere off-site, via a VPN. But basically on the left there, we see possibly some operations staff, some maintenance, some managers or engineering folks looking at process performance using some software with some dashboard kind of technology, perhaps looking in at KPIs and overview performance issues. We can also add there some alarm initiations if conditions go outside design to proactively, kind of point and shoot folks in that area. And then over on the right-hand side here, we see more of a maintenance and troubleshooting capabilities. Each of the Rockwell devices includes a web server utility. So without any specialty software, we can connect with a simple laptop with a web browser, Chrome or Internet Explorer, and get some first level device diagnostics. And then obviously based on that information, resolutions can be resolved, or problems can be resolved by simply, changing set points, installing some jumpers or whatever in the code. So, across the board, the remote monitoring really offers from visualization, from a operations standpoint, all the way down to helping maintenance and troubleshooting. So that pretty much wraps it up for me. I just wanted to give you all a quick overview of some of the, the benefits of Premier integration, and now we can better get some information from the drives and devices up to a plant or business level. So for me, that's a wrap.
Well, thank you, Gino and Stuart. That was great. We do have one question out here in the comments for you from Tim, and he would like to know, where can you find the faceplate that was discussed earlier, and can it be used on any panel view platform?
Can I answer this? Can you hear me on this then? Oh, yeah, okay, great. Thanks, Leanne. Yeah, the faceplates are available from the Rockwell website. It's the PCDC environment, so the product download center. There's a search utility. If you was to just enter, faceplates, there's a filter which hopefully would filter through to the particular devices you'd be interested in. So they're available for the PanelView series, the PanelView Plus series of products, 6 and 7. There's quite an extensive library there. And then for some of the newer 5000 series PanelViews, not quite as many yet, with it being a new product, but they're getting added on a daily basis. So I think it's fair to say both series of PanelViews have faceplates for most, if not all, of the larger motor starting devices. So that would include, the soft starts, VFDs and the likes. There may be some smaller devices that aren't yet available on 5000 that are for the PanelView Plus. I hope that answers this question.
I think you did a good job, Stuart. So while we wait to see if anyone else has follow-up questions, I'd like to reiterate that you can reach out to us even after this live stream has ended at mcmclive@mc-mc.com. We'll make sure that your question is passed along to Gino or Stuart, who can respond to you directly. Just be sure to let us know the name of this session in your email. I have another question here for you, Stuart,
Okay.
or Gino. Can you still use CCW for drive configuration, or is Studio 5000 replacing that?
No, Gino's better qualified than I, but I think I can answer this one. He'll nudge me if I get it wrong. But yeah, CCW is still available and obviously supports what would have been the old Drives Explorer package. That's not going to change. What Studio 5000 does for us is just another way to get to the same software and functionality. Obviously, there are a number of smaller standalone drive type applications where Studio may or may not be available. So CCW is that mechanism to do a point-to-point configuration or view where there is no Studio 5000 software. I hope that answers that one.
Perfect.
Thank you.
Gino says you were perfect. Did I hear that right?
That's exactly right.
It's very generous.
Okay, thank you, Gino and Stuart. And Gary, thanks for being out in the comments. And we want to thank all our live viewers for your time today. We hope this session was informative and engaging for you. We want to ask you to remember to subscribe to the McNaughton-McKay YouTube channel for more industry content. And we look forward to seeing you live again next week when Jeff Baker talks about wireless networking with ProTough Technology Industrial Wireless. I think that's it for today. Thank you so much again and have a great day.
Thanks, Leanne.